So we're going to now compute Gini index and entropy for a particular split, which is we're going to use 59.4. So our left side node, so this is the root node, the left side node will be less than or equal to 59.4. For income, right side will be greater than 59.4. For that split, so we have the left side node, we have the right side node. So what is the proportion of non-owners and owners for the left side? Okay, P sub 1 and P sub 2 like we have computed here. So P sub 1 will be what? Sum of, okay, so we need to compute, so this is non-owner, we have to start from G10, okay, we'll make that absolute reference, G10, all the way through G16. Okay, so that covers up to 59.4. Okay. That's the number of that's the number of owners, and divided by how many observations are there. So that will be sum of I10 through I16. So this part is our left side node. In this left side node, we have that many total records, right? And the balance will be the right side node. So these are the number of records on the left side node, and that many non-owners are there and that many owners are there. So probability of non-owner on the left side node is 0.875. So 1 minus that will be the owners. Now the formula for Gini index and entropy is the same as here. So I can just copy paste it, and that will give us the Gini index and entropy. Now we do the same thing on the other side. Okay. So this will be okay. So this is going to be the balance, right? So it will be G32, or we can try this. I haven't tried this. G17, sum of G17 through G31. So that's the number of non-owners, and the number of records is the sum here, this sum. So that would be divided by sum of I17 through I31, and we make I31 absolute reference. Okay, so this will be 1 minus, the owner proportion will be 1 minus that, and once again we can copy these two cells in here. So that will give us the Gini index and entropy of the second node. Now how good the split is, Gini and entropy are for a given node. what we want to do is to evaluate how good a split is. Okay, a split results in, here in this case, since this is binary split, we end up with two nodes, and now we have to take a weighted average of the index that we have computed. So that will give you the Gini index for the split itself. So for that, we need to weight these values by how many records there are in each of the two nodes. So we can use the proportion of records here. So that would be, we have to sum, okay, so G, what was that? It's the same here. So this part is the same. G10 so G10 through G16, when we divide by G30, we divide by not G, I'm sorry, not G, I. So we have split the, so this is the total number of records, and we have split in this fashion. So I10 through I16 will give you the number of records on the left side and the balance on the right side. So sum of I10, so here will be sum of I10 through I16 divided by I32. That's the total. So this will give us the proportion of records on the left side. And on the right side, proportion of records is 1 minus that. So now we can compute the weighted sum. So that, okay, times that. Okay. So you're taking the Gini of left multiplied by the proportion of records, and then that times this one. Right. So that will give us the weighted average Gini value for the left side. Now if I copy this across to this side, then that will be the average of the entropy, and then I'll move that down here. Okay. So this is a fairly high Gini value and entropy. Remember, for binary target, the maximum value for Gini index is 0.5 and entropy is 1.